Hey, Christian here. I'm one of the product engineers at PowerSync. I've recently been looking at what we call the right path of PowerSync and trying to figure out some potential proposals that we can discuss internally and externally with the public on how we could improve that area of the pipeline. Just a reminder, with PowerSync, which is a sync engine, we sync data down from a source database through our PowerSync service. So source database PowerSync service, and then to the client. And then client changes that are made locally are then taken through an upload path, or I guess we can call this the mutation path, which in some form gets processed, it reaches a backend API, and then eventually those changes that were processed end up in the source or backend database. So if you consider, I mean, most users that we have are on Postgres, so that means they need some database or backend API. They need a backend API in front of their database, which handles these changes that are uploaded from the client. If you a nice use case for some users is that they can adopt Superbase, which allows you to have a backend as a service, which handles that layer on top of your Postgres instance for you. And Superbase exposes a SDK which you can use on your client, which makes those writes directly to the database. So then you don't need a backend. And then another case that's interesting is MongoDB with their Atlas Sync. Their library supported the write path, or gave the write path for you, so you didn't have to worry about that. How data from the client ended up in the backend. So this is basically the flow: source, service, client, SQLite database, and then changes go through from here to a mutation queue, which is processed in the current state. There's a backend connector that you implement in the client, and that handles that processing, and then that goes to the API, which then in turn ends up in the database. So if we take a step back and we try to think of ways to make that easier, or to make it simpler to adopt for new users, and maybe make it more maintainable for existing users, we could consider the idea of not having the mapping logic in the client side. So what often happens with users now is that they need to basically take the CRUD transactions which are available to you in the upload data function, and either take them and map the data to the endpoint, or map them to other data types before they upload them. And then the backend, so basically reshaping the data from the CRUD queue in such a way that it's supported it's supported by the backend API. So if we wanted to turn that, or flip it a bit, make it an idea is to take the transactions that we get from the queue as is and upload them directly. And if we accept that idea, we can firstly standardize what we envision the right endpoint should be for most use cases. And it means we can move our mapping logic from the client to the backend, which is very nice. And for cases like Superbase, we can then this allows us to support something which a Superbase SDK doesn't currently support, which is transactions and rollbacks. So if we take it a step further, we can then introduce this communication protocol or spec between the client and the backend with a commonly used IDL, or specification language. In this case, for my proposal, it's OpenAPI. So we simply just define a CRUD transaction, and then obviously batches and potentially CRUD transactions as well in the API. And we get code gen on our client, we get code gen for handling the endpoint on the backend. And with that, we can then start considering something like standardizing how we map data received by the endpoint or processed by the endpoint, and then what do we do with it before it reaches the destination or source database. Because naturally, because we're taking data that is in the shape of coming from a SQLite database to, let's say, Postgres or MongoDB or MS SQL or MySQL, we sometimes need to map it, and the mapping can often be very straightforward, like from between two databases if it's similar, or maybe you have specific reasons why those two things aren't mapping one-to-one. For Postgres, for example, you could have something like the geo-based column types, which are a complex type which we, in the sync rules, when syncing down, we transform it. But then we, going from the SQLite database back to the source database again, we have to map it back. So we could introduce some form of mapping layer in the backend which does that part for us. And then another thing on top of that is being able to introduce potentially standardized persisters for every database that we support. So the idea behind some of this work is to make most cases simpler and give users an avenue for, or at least maybe hooks of some sort, to be able to break out and introduce custom logic where they have bespoke things that need to happen. So basically, we want to be able to support the happy path and make that as easy as possible to adopt, but then also make it easy to handle cases that are breaking out of the happy path. And if we do that, and users can buy in on that, then we've won in some sense. So this was just the introductory video. For the next video, I'll run through 3 POCs. The first POC introduces this concept of shoving all the mapping logic from the client and just pushing data as is to the backend, and then introducing a very basic mapping concept and persister concept. And then the second POC touches on something that we call a mutator pattern, which is kind of inspired by some other mutators we've seen in other sync engines. We define a mutator and a corresponding mutator on the backend, which for some projects that might, at least maybe enterprise level projects, it might make it easier to handle the complexity of having a lot of write logic in your project. And then the third POC goes through this idea of wedging the first POC's concepts into a superbase edge function. And the reason why we do that is because if that's implemented correctly and it's adopted, you don't have to worry about handling superbase transactions. That flow will kind of do it for you. It also standardizes a superbase write path without having all your logic in the client, which some people might not like. But yeah, let's see how that goes. Thanks for watching.